This video will continue to discuss the difference between an EPSP and an IPSP. By the time you're done watching this video, you should be able to explain how an EPSP could cause an action potential and how an IPSP could prevent an action potential. So let's start by reviewing what we've learned previously about EPSPs and IPSPs. Now remember, EPSP, that E stands for excitatory postsynaptic potential. The I stands for inhibitory postsynaptic potential. So if you think about that those terms, the PSP, postsynaptic potential, this is what's happening in the postsynaptic side of the synapse, that receiving neuron, whether it's the dendrite or a cell body. And that postsynaptic potential, meaning there's being a change in that electrical charge across the membrane there. And I, being inhibitory, means it's going to hyperpolarize that cell, take it farther away from zero. And E, being excitatory, means it's going to depolarize that cell, bring it closer to zero. So an EPSP is a graded depolarization. Now remember, that term graded means it decays over time and space. It gets weaker the farther away from where it was initiated, and it gets weaker the more time has passed. An IPSP is a graded hyperpolarization. Again, that term graded meaning it gets weaker over space, so the farther away from where it was initiated, as well as weaker as more time passes. So an EPSP is going to be caused by an excitatory neurotransmitter. And we'll talk about these a little bit later, but we'll learn that glutamate is our major excitatory neurotransmitter. An IPSP is going to be caused by an inhibitory neurotransmitter. And we'll learn later on that our major inhibitory neurotransmitter is GABA. So an EPSP is going to move the membrane towards threshold. We see how we're depolarizing towards threshold. An IPSP, on the other hand, moves the membrane away from threshold. So it's moving it away from threshold. Now, if an EPSP moves us towards threshold, it's more likely to contribute to causing an action potential. An IPSP moving us away from threshold is more likely to contribute to preventing an action potential. So this diagram is just showing you here we're at resting membrane potential. Remember that RMP. Here's that threshold for the neuron. It's not showing you here, but this would be time down here on this axis, and this would be millivolts on this axis. And this is showing you we're at rest. Something stimulates the cell. We have an EPSP. So an excitatory postsynaptic potential, depolarizing the cell towards threshold. Here we have an IPSP. You can see here how we're going further away from threshold. And now we have two EPSPs, and together they get that cell to threshold. So they don't look like they're occurring at the same time. So 1, 2 in rapid succession, that would be temporal summation. We have an action potential. Here's another diagram showing you some potential events that could occur at the synapse. Here we have -70 being our resting membrane potential, and up here -50 is our threshold. So we have an EPSP. Again, it's depolarizing us towards threshold, but not to threshold, so no action potential. Here we have this temporal summation of 2 EPSPs. We don't get to threshold, so there's no action potential. Here now we have 1, 2, 3 EPSPs, so they're occurring at 1, 2, 3 different times in rapid succession, so that's temporal summation. We get a little bit above threshold, so we have an action potential. Now here we have 3 simultaneous EPSPs. In order for 3 EPSPs to occur at the same time, they have to occur in different places. So we have simultaneous, which would be spatial summation. We get the threshold, so we have an action potential. And here's just showing you an IPSP, again moving you farther away from threshold. Here are some other wiring diagrams. So here, this is an A or B response. So when cell A fires an action potential, it stimulates X to a +1. When B fires an action potential, it stimulates X to +1. The threshold for cell X is 1. So if A fires an action potential and stimulates X, will X have an action potential? Yes, it got to +1. If B stimulates X, will X have an action potential? Yes, because it also stimulates at 2 plus 1, and that's our threshold. How about A and B together? Do we have a bigger action potential because A and B both stimulated X at the same time? Does that spatial summation lead to a bigger action potential? No, it doesn't, because of the all or none law. A and B together will cause the same action potential as A alone or B alone. So here, now the threshold for cell X is 2. So X has to get to a positive 2 in order for an action potential to occur. If A stimulates X, we get to a plus 1, no action potential occurs. If B stimulates X alone, we get to a plus 1, we don't reach threshold, no action potential occurs. If A and B fire simultaneously, stimulating X, 1 plus 1 is 2, threshold has been reached, and X will fire an action potential. Now here, just showing you some examples. The brain is actually a lot more complicated than this, but just giving you an idea of how it's the combination of EPSPs and IPSPs at that reach that axon hillock that determine if an action potential is going to occur. A stimulates X to plus 1, C minus 1. So pluses are excitatory, a minus 1 is inhibitory, and B to a plus 1. Again, threshold for X is 2. A alone doesn't get X to plus 2, so no action potential. B alone doesn't get X to 2, so no action potential. A and B firing simultaneously, so spatial summation, A and B together, 1 plus 1, that gives us 2, X would fire an action potential. Now let's say A, C, and B all stimulate X at the same time or around the same time. Will X fire an action potential? Do we get to a threshold of 2? 1 plus 1 minus 1 is only 1. So X will not reach threshold and will not fire an action potential. Just showing you how sometimes the excitatory stimulation gets counterbalanced or counteracted by an inhibitory stimulation. Here's yet another wiring diagram. Here we have 1, 2, 3 different excitatory inputs. So these are presynaptic inputs, axon terminals synapsing on these dendrites here, or cell body. Here we have one inhibitory presynaptic input. So here our resting memory potential is minus 70, our threshold is minus 50, and here we're going to see E1 stimulates the receiving neuron, this postsynaptic cell, and we get a little depolarization, but not enough to get to threshold, so no action potential. I1 here stimulates the postsynaptic neuron, causes a hyperpolarization, moves it farther away from threshold. Here, E1 and I1 fire at the same time, and they cancel each other out. Now E2 fires in rapid succession. E2, E2, E2. Temporal summation gets the cell to threshold and has an action potential occur. So again, 1, 2, 3 in rapid succession at the same place is temporal summation. Now we have E2 stimulates, depolarizes cell. It doesn't reach threshold. E3 stimulates the cell. It doesn't reach threshold. But E2 and E3 together at the same time in different locations in space stimulate the cell gets to threshold, and we have an action potential. Now here, simultaneous stimulation in different places in space is spatial summation.